So what we're doing today is we are working with matrices. We are working with matrices. Okay? So we did some stuff with matrices yesterday, didn't we? So a matrice, this isn't in your notes, but a matrice, so I'll just, you can watch this, it's not, I'm going to call this matrix A. So matrix A, we talked about yesterday, has dimensions, yes? Rows by columns. So this here is a what? 3 by 3. 3 by 3. Now we give this one a special name. We call it a square matrix. And any matrix that is square has the same number of rows as columns. Same number of rows as columns. So it kind of looks like a square, doesn't it? 3 by 3, 2 by 2, 4 by 4. Anything that has the same number of rows as columns is considered square. Now, each one of these is considered an element. And we'll talk about the elements as a lowercase a. We'll get more into this probably later on in the year if we have time. We'll cover a whole thing on matrices. So here, A11. And what this is talking about is, so matrix A, element, row 1, column 1. So the first row, first column is 2. That's just what it is. We could talk about row 3, column 2. Well, row 3, column 2 is 8, isn't it? Because it's just signifying that element in the matrix. Guys, heads up, heads up. And that's it. So this is kind of some of the stuff with matrices. Now, what we're really looking at today is two things, adding matrices and subtracting. When we add or subtract, one thing has to be true, is the dimensions of anything we add or subtract has to be the same. The dimensions have to match up. They have to line up. So here we have a 2 by 2. The only matrix I can add to a 2 by 2 matrix is another 2 by 2. And we add the elements. So if they're in the same spot, we add them together or we subtract them. So with addition or subtraction of matrices, the dimensions have to be the same and we add and subtract the corresponding elements. The sum or difference of two matrices with different dimensions is undefined. We can't do it. So when we look at this here, this first example of this here, so I wouldn't worry about adding, like, so the definition for it, add or subtract, we combine like terms and they have to be the same dimensions, okay? So I didn't fill that in, but really once we do the first example, it's going to make a whole lot of sense. So when we look at these here, what are the dimensions of the first one? This is a 2 by 2, yes? What's this one here? So are they the same? So we can add. Now, what I'm going to write down first is probably not something you'll end up writing a lot, because I'm going to show you how this works. So we're adding the elements together, yes, because there's addition in between them. There's an addition sign right here. So our first element here is a 2, yes? What matches up in the other one? So I'm going to do 2 plus 1. Now let's look at the next one. So our next spot is -1, and it matches up with -1 plus 2. Yeah. So anybody's mind blown by what we've done so far? No? So what do we do next? We would have, so 3 and 4, and then, and as I said at the beginning, you might not have to do this step here. So it's really, what are we doing? 2 plus 1 is, -1 plus 2 is 1, 3 plus 4 is 7, and then that's it. That's all we have to do here. We're just adding or subtracting those corresponding elements. Adding or subtracting the corresponding elements. And that's all we have to do to add two matrices together. That's all we have to do to add two matrices together. Yes.
On the first one, 2 plus 1 is a negative. On the, yeah, that one. You take it, oh, no, okay, never mind.
Yeah.
Putting it all down. Okay.
You're good. So we always add the corresponding elements from each of the different matrices. So the ones here won't combine because they're two different elements. They're two separate things. Any other questions on this here? You ready for the next one? Let's keep our heads up. Let's keep our heads up. So let's look at this one here. We have a 3 by 2. And what's our other one?
3 by 2.
So are these the same dimensions? Yes. And the only way we can add or subtract is if the dimensions for both matrices are the same. So our first row, first column is 2 minus negative 1. And then we're going to have 3 minus negative 3 minus 2. And what's next? We have 5 minus, and then 4 minus negative 2 minus negative, and 8 minus. Well, here negative and negative make a. So we get negative 3 minus 2 would be negative 5. Huh? We good? You're good. Then what's our next one? 5 minus 7 would be negative 2. 4 minus 8 is? Here, negative and negative would make a positive 3. And 8 minus 6 is? And that's it. That's all we have to do for this here. Any questions over anything we've done so far? We good with all this here? All right, we've got this down. We're good with this. Let's look at this next one. Okay. So let's go on and get started. So we're going to have negative 8 plus what? 1 plus negative 1, and then 3 plus what?
Nothing. They're not the same dimensions.
Because what is this? Say, and this is it. So this here is not, this is not possible because the dimensions have to be the same. The dimensions have to be the same. And that's the reason I just jumped straight into this and not check the dimensions. Because as we can see here, there's no number I can put with the 3. There's nothing I can add to the 3. And we can't add 0 because 0 is an element. It would be a number in there. So since they're not the same, they don't have the same dimensions, it's not possible. There's no way we can add or subtract if the dimensions aren't the same. Do we have any questions on adding or subtracting? Are we good with adding and subtracting? Do y'all need to see another example of adding or subtracting? Yes? So let's look at this one here. So what are the dimensions of this one? It's a 2 by 2. Here we have a.
2 by 2.
So what we're going to do is we're going to add the corresponding elements. So negative 1 is in the top left corner, and we're going to add to it the element that's in the top left corner. So we're going to add negative 1 and 6. So top left is 7, plus top left is, so bottom, so that's top right. Bottom left here is 5, plus, and then we'd have 3 plus 2. So negative 1 plus 6 would give us 7 plus negative 4 is 5 plus negative 8 is? And 3 plus 2 is? We good? We getting there? Okay.
Don't jinx us, please.
Let's try these here. Can I add, or can I subtract these two? Can we subtract these here from each other? We have a 2 by and a 2 by 1. And these actually have a special name. They're called column matrices because they only have, they're just a column. They're one column. So what we're going to have? We're going to have 2 minus
5 minus 0. Add 5.
That's it. That's all we have to do for this here. Any questions on this so far? Are we good? All right, so let's subtract these two. It's not possible because we have a 2 by 1 and a 1 by 2. So this doesn't work because the dimensions are not the same. So we can just write not possible and move on. Almost. I feel like we're good with these here. Scalar multiplication. When working with a matrices, a real number often called a scalar. To multiply the matrix by a scalar, multiply each number in the matrix by the scalar. So let's just look at this here. Our scalar here is what? 2. So I'm going to multiply every number inside that matrix by. So that means I'm going to have 2 times what? 3, and 2 times. And then I'm going to have 2 times, and 2 times. Then I'm going to have 2 times 2, and 2 times. So what is 2 times 3? It's 6. 2 times negative 2 is negative 4. 2 times 1 is. 2 times 5 is. 2 times 2 is. And 2 times 0 is. Questions on this here? Let's look at the next one. Now, I feel like y'all have gotten the scalar multiplications down. It's just pretty much multiplying everything inside by that number. But now we can do a combination of scalar multiplication and addition subtraction. So whenever we do that, these combine, the first thing we have to do is whatever the scalar is. We're going to do the scalar multiplication first and then add or subtract. So the first thing I'm going to do is I'm going to multiply everything in here by negative 3. So we'll have negative 3 times 5, negative 3 times 0, negative 3 times negative 2, and negative 3 times 4. Now, since nothing happened to this other matrix, we can just leave it alone. We're not going to do anything to it. So let's multiply here. So negative 3 times 5 is negative 15. Negative 3 times 0 is just 0. Negative 3 times negative 2, well, negative and negative gives us positive 6. And then we have negative 12. We good so far? Yes? Nothing too complicated so far? You good with this here? Okay. So we still have a 2 by 2 and a 2 by 2. So we can add these. So we're going to have negative 15 plus 0 plus 6 plus 12 plus 2. Negative 15 plus negative 1 is negative 16. 0 plus 7 is 7. 6 plus 3 is? Negative 12 plus 2 is negative 10. Huh? Yep, that's it. That is the final answer. So if there are scalars, whenever we're adding and subtracting, we do the scalars first, and then we add or subtract. Questions on this here? Do we need to see another example of either one of these with scalars, adding, subtracting? Okay. We'll finish this here because we're not going to worry about that. So